Hello students, I'm here to talk to you about this example 5. Just wait for the train to go by. All right, so in this example we're told to find theta given that tan theta is negative 1.68. So I know in my unit circle that tangent is the slope. So somewhere inside here I have oh, that's funny. I wanted to change my pen color. Okay, so inside my unit circle, and now of course my circle is not. Can I shift just the circle? Of course not. Oh, that's good. I'm sure you loved watching me move this line around. Okay, there we go. So we've got a circle, unit circle, radius 1. We know that tangent is the slope, so I'm going to put in a line that has a slope of negative 1.68 approximately. So that's going to be greater than my pi over 4 reference angle. So something like up here maybe. So I'm going to put my line through this way. So there's my line, and I can see that this line with a negative slope intersects at 2 different points. So what that implies is that I have 2 possibilities for my angle theta. It could either be here or all the way over here. And that's why it's important that we're told which quadrant we're thinking about, because otherwise we need to give multiple answers. So if tan theta is negative 1.68, theta is in the second quadrant, this is the angle that I'm thinking about. And we want to find theta, so I'm going to come over to my calculator. I'm going to put myself back into radian mode. Document settings, and then radians, because it doesn't say degrees anywhere, so we're always going to default to radians. Okay. And then we're going to do tan inverse. So now, remember, I think that it's always best to do tan inverse for the reference angle. So my reference angle would be positive 1.681. And I get an angle of 1.03 radians. So that is going to be somewhere here. So theta r. And of course, normally we denote our reference angle with prime is 1.03 rads. So the theta that we want is going to be pi minus the reference angle, because I'm going to go all the way to pi, subtract my reference angle. And let's do that. So pi minus the answer. And we get 2.11 radians. So let me show you what it would have looked like in the calculator if you had just done the tan inverse of the negative, because you might be thinking, Miss Slyman, why wouldn't I just do tan inverse of negative? Why do you want me to use the reference angle? Well, let me show you. One more. This gives us negative 1.03. It gave me my quadrant 4 angle. So I would still have to do some math to get to this angle, and I think it's easiest to start with your positive reference angle. So here's my theta r reference angle was here, theta prime, and I know that I'm going to do pi minus that to get the angle that I want.